Euclid. Euclid used the term postulate for the assumptions that were specific to geometry. Common notions, often called axioms, on the other hand, were assumptions used throughout mathematics and not specifically linked to geometry. Some of Euclid's axioms not in his order are given below. Things which are equal to the same thing are equal to one another. 2. If equals are added to equals, the whole are equal. 3. If equals are subtracted from equals, the remainders are equal. 4. Things which coincide with one another are equal to one another. 5. The whole is greater than the part. 6. Things which are double of the same thing are equal to one another. 7. Things which are halves of the same things are equal to one another. These common notions refers to magnitudes of some kind. The first common notion could be applied to plane figures. For example, if an area of a triangle equals the area of a rectangle and the area of a rectangle equals that of a square, then the area of the triangle also equals the area of the square. Magnitudes of the same kind can be compared and added, but magnitudes of different kinds cannot be compared. For example, a line cannot be added to a rectangle, nor can an angle be compared to a pentagon. The fourth axiom given above seems to say that if two things are identical, that is, they are the same, then they are equal. In other words, everything equals itself. It is the justification of the principle of superposition. Axiom 5 gives us the definition of greater than. For example, if a quantity B is a part of another quantity A, then A can be written as the sum of B and some third quantity C. Symbolically, A greater than B means that there is some C such that A is equal to B plus C. Now let us discuss Euclid's 5 postulates. They are: Postulate 1. A straight line may be drawn from any one point to any other point. Axiom 5.1. Given two distinct points, there is a unique line that passes through them. Postulate 2. A terminated line can be produced indefinitely. Postulate 3. A circle can be drawn with any center and any radius. Postulate 4. All right angles are equal to one another. Postulate 5. If a straight line falling on two straight lines makes the interior angles on the same side of it taken together less than two right angles, then the two straight lines, if produced indefinitely, meet on that side on which the sum of angles is less than two right angles. A brief look at the 5 postulates brings to your notice that postulate 5 is far more complex than any other postulate. On the other hand, postulate 1 through 4 are so simple and obvious that these are taken as self-evident truths. However, it is not possible to prove them, so these statements are accepted without any proof. Because of its complexity, the 5th postulate will be given more attention in the next section. Nowadays, postulates and axioms are terms that are used interchangeably and in the same sense. Postulate is actually a verb. When we say let us postulate, we mean let us make some statement based on the observed phenomenon in the universe. Its truth or validity is checked afterwards. If it is true, then it is accepted as a postulate. A system of axioms is called consistent if it is impossible to deduce from these axioms a statement that contradicts any axiom or previously proved statement. So, when any system of axioms is given, it needs to be ensured that the system is consistent. After Euclid stated his postulates and axioms, he used them to prove other results. Then, using these results, he proved some more results by applying deductive reasoning. The statements that were proved are called propositions or theorems. Euclid deduced 465 propositions in a logical chain using his axioms, postulates, definitions, and theorems proved earlier in the chain. In the next few chapters on geometry, in this coming chapters of your class 9 geometry, we will be using here CBSE will be using these axioms to prove some theorems. Now let us see in the NCERT books. This is an NCERT book, so this book they will be using this Euclid's axioms to prove some theorems. Equivalent versions of Euclid's fifth postulate. Euclid's fifth postulate is very significant in the history of mathematics. There are several equivalent versions of this postulate. One of them is Playfair's axioms, given by a Scottish mathematician, John Playfair, in 1729, as stated below. So, Playfair states that for every line L and for every point P not lying on L, there exists a unique line M passing through P and parallel to L. So, you can refer your NCERT book, page number 86, this figure 5.11. So, this result can also be stated in the following form. Two distinct intersecting lines cannot be parallel to the same line. Euclid did not require his fifth postulate to prove his first 28 theorems. Many mathematicians, including him, were convinced that the fifth postulate is actually a theorem that can be proved using just the first four postulates and other axioms. However, all attempts to prove the fifth postulate as a theorem have failed, but these efforts have led to a great achievement, the creation of several other geometries. These geometries are quite different from Euclidean geometry. They are called non-Euclidean geometries. Their creation is considered a landmark in the history of thought because till then, everyone had believed that Euclid was the only geometry and the world itself was Euclidean. Now, the geometry of the universe we live in has been shown to be a non-Euclidean geometry. In fact, it is called spherical geometry. In spherical geometry, lines are not straight. They are parts of great circles, that is, circles obtained by the intersection of a sphere and planes passing through the center of the sphere. So, please subscribe this channel for more videos and audios and exercise solved, examples explained, and in the coming videos I will be uploading more videos and audios for quick revision, and thus you will be able to score more marks. So please subscribe this channel.